Hi, I'm Joe Graydon.
I'm Terry Graydon. Welcome to this podcast of the People's Pharmacy, where we bring you the stories behind the health headlines.
This podcast is brought to you by Redix Industries, makers of Utterly Smooth Body Cream. 800-345-7339, on the web at uttercream.com. What is it about a hug that's so reassuring? We often take the sense of touch for granted, but it's essential for our well-being. This is the People's Pharmacy with Terry and Joe Graydon.
The sense of touch allows for the pleasure of a caress, whether we're stroking a pet or cuddling an infant. It allows for the bonding between parents and children, as well as between sexual partners.
We express our emotions as feelings. That's because our sense of touch is profoundly intertwined with the neurological wiring that provides feedback on how we are interacting with the world around us. Whether offering pain or pleasure, touch is central.
Coming up on the People's Pharmacy, the science of the sense of touch.
First, this news.
In the People's Pharmacy Health Headlines, noted nutrition experts are urging the Departments of Agriculture and Health and Human Services to forget about fat in the new dietary guidelines for Americans. The guidelines will be issued later this year, following recommendations from an expert committee. Dr. Dariush Mozaffarian of Tufts University and Dr. David Ludwig of Boston Children's Hospital write in JAMA that previous guidelines telling Americans to limit fat contributed to the obesity epidemic. Avoiding fat led people to eat more sugar, bread, rice, chips, crackers, and bakery desserts. These are major sources of calories in the American diet. According to these experts, Americans should be focusing on eating more vegetables and healthful high-fat foods like avocados, fish, and nuts, rather than cutting out fat.
Eating your bread at the start of your meal could be a mistake, especially if you have diabetes. That's the conclusion of a small metabolic study carried out at the Weight Control Center at Weill Cornell Medical College. In this study, 11 obese people with type 2 diabetes were fed the same meal twice, a week apart. It included ciabatta bread, orange juice, chicken breast, lettuce and tomato salad, and broccoli with butter. Blood glucose levels were carefully monitored. When the volunteers ate the bread and drank the orange juice 15 minutes after the protein, vegetables, and fat, their blood sugar levels were about 30% lower than when they consumed the carbs first. The researchers suggest that rather than telling patients to avoid carbs, which is difficult, they counsel them to eat the carbs later in the meal. That could have positive, long-lasting health benefits.
The federal government issues physical activity guidelines for Americans from time to time. The latest came out in 2008, recommending that all of us get at least 150 minutes of moderate activity each week. That works out to half an hour every weekday. A new study shows that this makes a difference. Analyzing data from 6 studies with a total of more than 600,000 participants showed that people who met these leisure time activity recommendations reduced their risk of dying by 31% over 14 years. The benefit was similar for cancer and heart disease deaths. The more people exercised, the more benefit they got. But the biggest difference was between couch potatoes who got little or no exercise and those who met the minimum recommendations.
Australian researchers also looked at activity level and longevity. In this study, over 200,000 adults ranging in age from 45 through 75 were tracked from February 2006 through June 2014. Those who engaged in moderate to vigorous physical activity were less likely to die during the study period. Vigorous exercise provided people even more protection. The authors point out that lack of time is a major barrier to physical activity. Because vigorous activity is more time efficient in achieving health benefits than moderate activity, Promoting vigorous activity might be particularly fruitful for those for whom insufficient time is a major barrier. They conclude that doing some vigorous activity might be important for increasing longevity among middle-aged and older adults.
People who are watching their weight, literally, can benefit. A new study published in the Journal of Obesity shows that people who are trying to lose weight or maintain weight loss do better if they weigh themselves every day. Keeping track of weight on a spreadsheet or graph was the other piece that made a difference. The 2-year study included 162 people randomly assigned to a weight loss or a control group. Those in the weight loss group were told to lose 1% of their body weight any way they chose. They needed to maintain their new weight for 10 days, then were challenged to lose another 1%. The overall weight loss goal was 10% of body weight. Daily weighing and recording weight acted to reinforce behavior such as skipping snacks or walking more. The researchers said this worked significantly better for men than for women, though they don't know why. And that's the health news from the People's Pharmacy this week. Welcome to the People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. Today we're talking about touch. This sense doesn't get much attention or respect, not like sight or hearing does. And yet touch is crucial to our sense of well-being and our health.
Without a sense of touch, we could hurt ourselves and not realize it until too late. Pain is a great protector, even though it sometimes gets out of control.
And we wouldn't experience the pleasure of sex without a sense of touch.
We describe our emotions as feelings, and we feel not just with our fingers, but with our entire bodies.
We're talking with Dr. David J. Linden. He's professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. He was formerly the chief editor of the Journal of Neurophysiology. Dr. Linden is the author of several books, including The Accidental Mind, The Compass of Pleasure, and most recently, Touch, The Science of Hand, Heart, and Mind.
Welcome to the People's Pharmacy, Dr. Linden.
Thanks for having me on.
Dr. Linden, several years ago, I lost the hearing in my right ear. I was just so disoriented for almost a week. But large doses of prednisone brought it back. And when I was a teenager, I almost lost the sight in one of my eyes. And the ophthalmologist said that if that eye went, it was entirely possible the other eye might go too. And I was very conscious of my sense of sight. Both of those experiences were incredibly scary. And like a lot of people, I vowed to never take my sight or hearing for granted again. But, the sense of touch is not something most of us think about the way we do other senses. Why is it equally or perhaps even more crucial?
Well, I think the reason why we take it for granted is because we can't imagine it being gone. Touch is an always-on sense. If you are sighted, you can imagine being blind by closing your eyes, and you can plug your ears, and you can pinch your nose, and imagine losing those senses. But because touch is always on, it's hard to imagine it being lost, and as a result, it fades into the background. I think the thing to realize is that, unlike other senses, touch is not optional for early human development. So you can be born blind and grow up just fine. Your mind will be fine. Your body will be fine. You can be born deaf, and the same situation occurs. But if you're born with a sense of touch, but you don't receive loving touch in the first 2 years of your life, then a disaster unfolds. And this is what happened in orphanages in Romania in the 1980s and 90s under the Ceausescu regime and what followed. These kids didn't receive loving touch in the first 2 years of their life, and they developed compulsive, self-soothing rocking motions and attachment disorders and cognitive delays. And it wasn't just mental problems. They also had slowed growth, problems with the development of the immune system and the gastrointestinal system. And if loving touch didn't come in the first 2 years of life, then these problems would persist throughout adulthood.
Do we have any idea why loving touch, and I'll ask you actually to explain what loving touch is, why is it so important for newborn development?
Well, that's a great question, and I wish I could give you a cascade of biological signals that said when you get touched in a loving way, this happens and this happens and this happens, and that's how it impacts development. We don't actually understand it very well at all. We do know that when rats and mice receive loving touch from their mothers, which basically means licking and grooming in the case of those animals, that there are changes in the expressions of genes, epigenetic changes, not changes in the genetic code, but changes in how genes are expressed that include changes in the signaling for stress hormones and their receptors and many, many other things. So right now we do not have a detailed biochemical understanding. What we do know is that when you look at rat and mouse pups that receive only a small amount of licking and grooming from their mothers when they're growing up, they grow up to have higher levels of stress hormones, to be more fearful, less willing to explore new environments, less willing to try new foods.
So although we can't make a direct translation from rats and mice to humans, we might anticipate, perhaps, that babies who don't get touched lovingly enough might grow up to be more anxious and fearful individuals.
Well, we already know that that's the case, yes. And they have many more problems than anxiety and fear. They have all these other problems I just mentioned.
Dr. Linden, anyone who has ever pet a cat or a dog or stroked a horse, or in the case of my Uncle Leo, a cow, because he was a dairy cattleman. What is it about that act of petting a cat and listening to it purr that is so comforting?
Well, that's a great question. We know a lot about the pathways on the cat's end or the cow's end. We don't know nearly as much about the detailed flow of signals that's involved in giving a caress. What we do know is that in hairy skin, there are special caress sensors. There are nerve endings called C-tactile fibers, and these wrap around the base of hair follicles, and they sense hair deflection. They can also sense the direction of hair deflection, which is why it feels so different to have the hair on your arm caressed with the grain as opposed to against the grain. And we all know that if you pet a cat against the grain, you're very likely to get your hand bitten. And these C-tactile fibers send messages to two different parts of the brain. One of them is involved in just the facts of touch. Where in my body am I being touched? How intensively? And with what quality? And then there is a very strong activation of a separate region in the brain called the posterior insula, which is important for decoding the emotional valence of touch, and that's what makes a caress feel good. It's also what makes pain feel bad and what makes an orgasm feel good.
So the posterior insula, whatever that is, it seems to be really important in telling us this feels good and this doesn't. Is that right?
It's totally important, and if you have damage to it, then you have a very particular set of problems. So, for example, if you have damage to your posterior insula, to the emotional pain center, and then I were to come along and whack you on the thumb with a hammer, instead of saying, "Oh, ow, oh, that hurts, that's terrible," the way someone would normally, you would say in a very flat voice, "Yes, it hurts a lot. It's very bad. It's on my thumb. It's throbbing now. Yes, that's pain." But it would have no emotional resonance for you at all. It's important to note that it's not the same as being a masochist who enjoys pain. For masochists, pain has emotional resonance. It just has positive emotional resonance. People with this condition called pain asymbolia have no emotional content to their pain whatsoever. The same thing can happen for orgasm. If you have damage to your brain's pleasure circuitry and these emotional touch centers, you can have orgasms that are more like a sneeze than like the intensely positively emotional experience that most people would have.
Now, are there people who actually can't sense pain?
There are. It's an extremely rare genetic disease. So there is a gene called SCN9A, and it makes a protein called the voltage-gated sodium channel, which is important for sending electrical signals from nerve endings ultimately up to the brain. And SCN9A is special because it's only in those nerve endings that subserve pain. It's not in the nerve endings that subserve heat and cold and itch and pressure and vibration and all the other different aspects of touch sense. The people who have this congenital total insensitivity to pain have actually terrible lives. You might think, oh, no pain, sign me up for that. That would be great. I would love to have that. But it's not blissful, because if you don't have pain, you don't have the protective reflexes that you need to survive. And so people who have this lack of pain, they rub grit into their eyes unknowingly. They swallow boiling liquids and scald the esophagus. They put on their clothes and their shoes too tight, and they cut into their skin and they get bacterial infections. And in truth, it's very hard to live past the age of 25 if you don't have a sense of pain.
Dr. Linden, health professionals like doctors and nurses often use something called a pain scale. You know, how bad is your pain on a scale of 1 to 10? Is that a pretty decent way of assessing someone's pain?
Well, it's reasonable in a very rough and ready way. The problem is that people are calibrated somewhat differently. So if the worst pain you've ever had in your life is not that bad, then you might rate something as a 10 if it's equal to the worst pain you ever had. But that may not be the same for someone else who has experienced much worse pain at some other time in their life. So as a consequence, it's not useless, but it's not accurate either.
You're listening to Dr. David J. Linden. He's a professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. In the past, he was chief editor of the Journal of Neurophysiology. Dr. Linden has written a number of books: The Accidental Mind, The Compass of Pleasure, and the one we're talking about today, Touch, the Science of Hand, Heart, and Mind.
Terry, you know, Dr. Linden's point that that 1 to 10 scale is very subjective, but nevertheless important for the individual.
Well, absolutely. And pain is subjective. We don't have any objective measures of pain.
We're going to take a break. After we come back, we'll find out why pain can persist.
How do different people react differently to pain?
You'll find out about yoga for pain relief.
What about phantom pain? What's that?
We'll also explore how sensitivity to touch differs in various parts of the body, how that affects dopamine, and how it can influence sexual arousal.
You're listening to The People's Pharmacy with Joe and Terry Graydon. Thanks for listening to this podcast of The People's Pharmacy. If you like it, why not rate or review it in the iTunes store? We'd appreciate it.
Welcome back to The People's Pharmacy. I'm Joe Graydon.
And I'm Terry Graydon. The People's Pharmacy is made possible in part by Red X Industries, makers of utterly smooth creams and lotions that deeply moisturize to make dry skin feel soft and smooth. 800-345-7339. online at uttercream.com.
If you'd like to order a CD of this show or any other broadcast, you can call 800-732-2334. Today's show is number 998. That number again, 800-732-2334, online at peoplespharmacy.com.
Today on the People's Pharmacy, the topic is touch. We should mention here that we will be discussing sexual sensation over the next 20 minutes. The tone is scientific, but the subject matter may not be appropriate for all listeners.
Our guest is Dr. David J. Linden. He is professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. He was formerly the chief editor of the Journal of Neurophysiology. Dr. Linden is the author of several books, including The Accidental Mind, The Compass of Pleasure, and most recently, Touch, The Science of Hand, Heart, and Mind.
Dr. Linden, one of the things that we've observed is that very often you have a pain, you hit your thumb with a hammer, it hurts, and you get over it, and everything's fine. But there are situations in which someone has a pain. For example, they wrench their back. The back hurts, and it doesn't get better. Why does pain sometimes persist?
Well, pain persists for a couple of different reasons. Pain can outlast the initial injury because lingering chronic pain can be adaptive in the sense that if you have an injury, you may want to avoid contact to that area, and so it is worthwhile to have it remain sensitive. So if you've just wrenched your back, you want to avoid putting further strain on it, and so some lingering pain that will cue you to not do that is a good idea. The problem is that in many cases, chronic pain outlasts its usefulness, and we don't entirely understand how that happens. It may well be that the experience of very intense pain actually changes the neural circuits that process pain, both in the brain and the spinal cord, and leaves them that way for a long period of time, much in the same way that a memory can change the brain for a long period of time to encode the memory trace. Now, what we do know is that when people have chronic pain, they've got anxiety that goes with it. When will my pain go away? Will it get worse? When will it come back? And the problem is that you have a negative feedback loop there. So the anxiety makes the pain worse. The pain makes the anxiety worse. So to break that loop, you can either give anti-anxiety medications like benzodiazepines, or even better, you can engage in anti-anxiety strategies like mindfulness, meditation, prayer, and exercise, all have which now been shown in well-controlled studies to attenuate chronic pain.
Now, Dr. Linden, people have different responses to pain. For example, Terry's mom is one of those people who is very stoic. Cut to the bone, I can handle it, no problem. My mother, on the other hand, was very sensitive to pain. I mean, if she had a stomach ache, the world was coming to an end. I remember when we were getting married, on the day we were getting married, my dad was cutting the grass, and he got stung by a bunch of yellow jackets. And it was like, he didn't even notice it. He just had to get the grass cut, and he just kept on going. So is there a difference in how people respond to pain?
Well, yes, there are differences of two varieties. One of them is that there are differences in pain threshold and the perception of pain unpleasantness between individuals. But even in the same person, there can be enormous differences based upon the circumstance. And one of the examples I give in my book, and which I think many people have heard about, has to do with soldiers in combat. So I tell the story of Dwayne Turner, a U.S. Army medic who came under fire with his unit in Iraq, and a grenade came over the wall and exploded, and he took fragments up and down his body, and he didn't even notice. And in the next few minutes, he ran out under fire, dragged 12 of his injured comrades to safety. He was awarded the Silver Star for Valor. And during this period, he was shot twice, and he didn't even notice. And the other guys in his unit said, "Hey, Dwayne, you've been hit." And he said, no, that's just some other guy's blood that got on me. And they said, "No, you've been hit." he didn't even realize that he had taken these massive injuries. And it doesn't diminish his heroism at all to note that this is actually a very common phenomenon in combat. Now, when Duane Turner was in the field hospital 3 days later and someone bungled the blood draw from his arm, which, hurts a little bit, he complained about it just like anyone else would. Soldiers are not superhumans. They are normal people who, when thrust into the heat of battle and all the emotion and focus and context that provides, those experiences activate higher order parts of our brain which send messages to both the emotional and the discriminative pain perception centers and damp them down in that circumstance. Now, there are also differences between individuals, and we don't understand these as well. What we do know is that people who become depressed tend to report more chronic pain. People who report more chronic pain tend to become depressed. There may well also be individual genetic variation that underlies things like difference in pain perception. So we know, for example, that some people like cilantro and some people hate it. And we now know that all people who hate cilantro have a mutation in a particular odorant receptor in the nose that underlies their cilantro hatred. It may be that there are subtle mutations in the genes that encode aspects of pain sensing in the nerve endings or in different regions of the brain, and that genetic variation might underlie variation between individuals in things like pain threshold. But right now, that's just speculation. We don't actually have examples.
We recently had an opportunity to interview one of the world's foremost authorities on post-traumatic stress disorder. And when we asked him, how do you break that cycle? He said, yoga. And we went, what? Yoga?
Or he said, learn to tango.
Or he said, join a theater troupe and get out of yourself and play another role. And we were having a hard time processing that. But he said, no, that's really helpful. It sounds like exercise or yoga might be helpful for somebody who has chronic pain.
Yeah, I think the important thing to realize is that when you hear about these behavioral therapies, it's not like they exist on some ethereal plane that's different from biology. When they work, just like the same way when talk therapy works, it works because you are changing the biochemistry of the brain. And in the case of anxiety and chronic pain, we know that the brain's anxiety centers in the frontal cortex send messages to the posterior insula, the brain's emotional pain center, that can upregulate pain unpleasantness. And we know that if we can reduce that anxiety through other means, we can break the feedback of signals between these two brain regions. And we can do that through any one of a number of behavioral interventions. But ultimately, it works because it works on a biological substrate.
What about phantom limb pain?
Phantom limb pain, which is pain that occurs after a limb has been removed by an accident or surgically, is still rather poorly understood. What we believe is that when an amputation is performed, it used to be that it was done under general anesthesia only. And that means that the pain signals would still be going from the site of the saw to the spinal cord. It's just that they would get blocked before they activated the brain's pain centers. But the problem is the pain signals would still be coming into the spinal cord. And the thought is that when intense pain signals come into the spinal cord, they actually produce long-lasting changes in the spinal cord pain circuitry that can underlie phantom limb pain. So what is done now is when you have an amputation, in addition to giving a general anesthetic, you also give a local at the site of the amputation so those signals don't get to the spinal cord at all. And when you do that, it reduces but does not eliminate the incidence of phantom limb pain occurring.
You're listening to Dr. David Linden. He's a professor of neuroscience at Johns Hopkins University. His book is Touch: The Science of Hand, Heart, and Mind.
Dr. Linden, when we talk about the sense of touch, although, as you have pointed out, touch is all over our body, and we can touch with our tongue and we can touch with our toe, but we tend to think of our hands because human hands are really specialized in the sense of touch, and we use them a lot for finding out what things feel like. Can you tell us a little bit about how hands got so specialized?
Well, yes. So there are certain areas of the skin that are well endowed with a particular kind of nerve ending, called a fine touch sensor called a Merkel ending. And this is what you need to discern fine texture and fine spatial features. This is what you would need to read Braille dots, for example. And so you can read Braille dots with your fingertips, you can read them with your lips, you can read them with your tongue, but you can't read them with the small of your back, for example, because the density of Merkel endings in the skin of the small of your back is just too low. As a matter of fact, if you do an experiment and you take a couple of pencil points and you press them against your back about a centimeter apart, you can't even actually tell if it's 2 points or 1 point because your fine touch sense in that region is so poor. And you might think, well, there are other areas of the body that are very sensitive, like the cornea of the eye or the genitals, and can you do fine touch with them? And the answer is no. They're sensitive in the way that a very tiny deflection of the skin is very easy to detect. So if you get a little bit of grit in your eye, it hurts like crazy. But think about it. When you get a little bit of grit in your eye, knowing exactly precisely where it is in your eye is very difficult. That's what we call protopathic sensation. So because of a lack of Merkel endings, we can't read Braille with, say, the cornea of our eye or the small of our back or the skin of the genital.
So it is sensitive, but doesn't have that kind of discrimination power.
No, but it brings up this interesting point, and that is we can have an orgasm from anything. You can think yourself to an orgasm. You can have an orgasm even if you have spinal cord injury and your brain can't get signals from most of your body. You can have an orgasm from being touched anywhere on your body. Nonetheless, there's something special about the external clitoris in women and the glans penis in men in terms of delivering the most powerful sexual sensations. And why is that? You would imagine that perhaps if you looked at this skin under a microscope, you would see some structure that would say, all right, this is why these areas produce such strong sexual sensations. And sure enough, there is a specialized kind of loopy nerve ending in both of these regions at high density, and it's called a mucocutaneous end organ. But embarrassingly, we don't actually know that this particular nerve ending is the basis of sexual sensation. It's a good candidate, but we don't have experiments that prove that definitively. And given the current state of funding at the National Institutes of Health, we're unlikely to know anytime soon.
It doesn't seem like the sort of thing that would have a high priority of funding. You're right.
Well, but it should. I mean, when you think—
Oh, I agree completely.
Sexual sensation is one of the key motivators of human behavior, and we spend all kinds of attention with our laws and our religious ideas and our cultural ideas talking about it and regulating it. And nonetheless, embarrassingly for biologists, I can't even tell you what cell type underlies this sexual sensation.
Well, do we know anything about what causes sexual arousal?
We know a lot about what causes sexual arousal, and of course it can happen from all kinds of stimuli, from sights and sounds and smells as well as touches. What we do know is that there are aspects of sexual arousal that are reflexes, that are spinal reflexes, that don't even involve the brain. So, for example, people who have spinal cord injury such that they cannot feel their genitals still can have reflexive erection or lubrication if their genitals are stimulated, as long as the nerves from the genitals to the spinal cord and back are still intact.
Dr. Linden, we were just talking about sex and sensation and responsiveness. And there was an article in the New York Times not too long ago in which a man was kind of describing his frustration because his wife of many years had kind of lost her libido. She just wasn't interested in sex very much anymore, and he was still quite interested. And then she developed Parkinson's disease and had to be put on a medication that actually affected the dopaminergic pathways in the brain, affected dopamine, very critical neurochemical. And now all of a sudden her libido was greater than his. And after a while, it became a little challenging for him to keep up with her. Can you tell us a little bit more about libido?
Certainly. So libido is controlled by a number of different neurotransmitters in the brain, most notably serotonin and dopamine. I think many of your listeners are aware that antidepressant medications of the serotonin-specific reuptake inhibitor, or SSRI class, often reduce libido and also make it harder to achieve orgasm when sex is engaged in. So serotonin is an important regulator of libido. Dopamine is also an important regulator of libido. And dopamine is the main neurotransmitter of the brain's pleasure circuit, which is activated during orgasm. It's also activated when we eat food when we're hungry, when we smoke a cigarette, when we drink alcohol or take a number of different drugs like cannabis or heroin or cocaine or amphetamines. Now, when people have Parkinson's disease, the neurons in the pleasure circuitry that secrete dopamine gradually die. And a therapy that's given along the way is to give drugs that either increase dopamine synthesis or a separate set of drugs that mimic dopamine. And if these drugs are given at too high a dose, then not only is libido increased, but generally risky behaviors increase. People tend to gamble a lot. They don't just have libido, but they're more likely to have unprotected sex or to engage in compulsive shopping. So dopamine is involved in a whole set of pleasure-seeking and risk-taking activities.
You're listening to Dr. David J. Linden. He's a professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. He was formerly editor of the Journal of Neurophysiology. Dr. Linden has written a number of books. They include The Accidental Mind, The Compass of Pleasure, and the one we're talking about today, Touch, The Science of Hand, Heart, and Mind.
After the break, we'll talk about the pleasure of touch.
Why do some people like hugs while they make others cringe?
We'll find out about the cultural differences in touch.
Why can't we tickle ourselves?
Find out how to nurture your sense of touch.
Learn how peripheral neuropathy can affect this vital sense.
How does touch interact with taste? Crunch in your mouth matters. What about spice?
You're listening to The People's Pharmacy with Joe and Terry Graydon.
If you value the health information you get when you listen to The People's Pharmacy, consider subscribing to our email newsletter. You'll get the latest health news and information on upcoming podcasts delivered to your inbox twice a week. Look for the link at peoplespharmacy.com.
Welcome back to The People's Pharmacy. I'm Terry Graydon.
And I'm Joe Graydon. The People's Pharmacy is brought to you in part by Red-X Industries, makers of utterly smooth foot cream with shea butter, helping dry, cracked feet feel soft and smooth. The number's 800-345-7339. The website is uttercream.com.
If you'd like to order a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is number 998. The number to call, 800-732-2334. 2334, or find it online at peoplespharmacy.com.
Today we're talking about feeling. The sense of touch is embedded in the interplay between our skin all over our body and our nervous systems. This is a source of both pain and pleasure.
Our guest is Dr. David J. Linden. He's a professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. In the past, he was chief editor of the Journal of Neurophysiology. Dr. Linden has written a number of books: The Accidental Mind, The Compass of Pleasure, as well as the one we're talking about today, Touch, The Science of Hand, Heart, and Mind.
Speaking of pleasure, one of the things that I find incredibly pleasurable is a hug. And I keep wondering, what is it about a hug or a massage that is so powerful at that neurological level? And, for some people, myself, I have to admit, a hair massage is like the ultimate. It's like I zone out when I'm getting a hair massage. Other people like to have their back scratched. Or, some people, love to be tickled. Other people hate to be tickled. Can you help us understand a little bit more about these sensations, these feelings, and why for some they're so wonderful and other people, I hate to be touched. I don't want to be hugged. How do we explain that?
Well, there is a lot of individual variation. What we do know is that there is a dedicated caress sensing system in the skin. It's only present in the hairy skin. It's not present in the hairless skin of the palms of the hands and the lips and a few other places. But these C-tactile fibers, which wrap around the base of hair follicles and sense hair deflection, they are specific caress sensors. They are most activated by precisely those caresses that we find to be most pleasurable. And think about this. Imagine if someone's caressing your arm and they do it very, very, very slowly so their hand is crawling along. Well, that doesn't feel good. And likewise, if they very rapidly skim their hand over your arm, that doesn't feel good either. There's an intermediate velocity and an intermediate pressure, both of which you have to achieve in order to activate these C-tactile nerve fibers and, as a consequence, activate the pleasurable touch centers in the posterior insula of the brain. Now, as far as inter-individual variation goes, we know that responses to touching can be altered a lot by people's individual life experience and cultural context and ideas of propriety and faith, but there may well also be genetic variation that underlies why some people like being touched in certain ways and other people not.
Well, as an anthropologist, I'm always interested in cultural differences. I wonder if you can tell us a little bit about those.
Well, one of the best examples comes from a anthropologist named Sidney Girard. In the 1960s, he spied on people in cafes in different places around the world. And he looked not just at romantic partners, but at friends and business associates. And he found that in San Juan, Puerto Rico, there were on average 170 touches per hour when a pair of people were sitting in a cafe. And in Florida, this was reduced to 30 touches an hour, and in London it was 0 touches per hour. And so I think this just underlies the idea that there is enormous cultural influence over interpersonal touch.
Dr. Linden, why can't we tickle ourselves?
Oh, I love that question. The reason we can't tickle ourselves is because our brains are hardwired to disregard the sensory consequences that result from our own movements. It's the same reason that when you're walking down the street and you're causing your clothes to move against your body, you don't attend to those sensations very strongly. They fade into the background. Whereas if you were stopped and then your clothes moved against your body and created those very same sensations, you would attend to that very strongly and want to know. The reason for having this is that we want to pay attention to the sensory consequences of things in the outside world to a much greater degree than the sensory consequences of our own motions. So when you go to tickle yourself, your brain is sending signals to the muscles in your arm and your fingers to produce the tickling motion. But a copy of those signals is also being sent to a brain region called the cerebellum. And the cerebellum changes them into inhibitory signals and passes them on to the primary somatosensory cortex, the part of your brain that processes the touch signals. And those inhibitory signals damp down that touch sensation. So that's the reason why you can't tickle yourself. It's also the reason why some people who have damage to the cerebellum can indeed tickle themselves.
And some people find tickling delightful, and other people find tickling painful. Do we have any understanding of why?
We don't. That has not been studied. Another related phenomenon that I think many people are aware of is that folks on the autism spectrum are also often averse to interpersonal touch and will shun caresses, will shun hugs. And if you look at the nerve endings in the skin of people with autism, there is nothing structurally, obviously, different. So we do not yet understand the basis of that inter-individual difference.
Well, I was so fascinated when we read Temple Grandin's first book. She is a person with autism who has written some beautiful, beautiful books and done some very interesting research in veterinary science. But in her first book, she described growing up and how much she hated to be hugged or touched, but she loved the sensation of being squeezed tightly, and she invented her own sort of squeeze machine or hug machine that gave her a mechanical hug. So obviously, it's not strictly the sensation. It's got something to do with the interaction as well.
Well, I think it may be partly that, or it may be that her squeeze machine was very good at altering what we call proprioceptive receptors. That is to say, a specialized kind of touch receptor that's present in muscles that's normally there to let you know where your limbs are in space. So it may be that for whatever reason, the touch receptors that are in the skin don't produce positive sensations in people with autism for some reason we don't understand. But the proprioceptors do. And right now, the biology underlying this still remains a mystery.
Well, speaking of proprioception in the skin, I wonder if there is any biological basis for the use of acupuncture where you're actually sticking needles into the skin.
That's a great question. So acupuncture is used for lots of different things, for relief of pain and for relief of inflammation and for a number of chronic medical conditions. And the only aspect of this that I can really speak to has to do with acupuncture for relief of pain. And what we do now know from several studies is that acupuncture analgesia appears to work by activating the brain's natural opiate-like systems, the endorphins and enkephalins, because if you give a drug that block the endorphin receptors, in particular what's called the mu-opioid receptor, then you will block the analgesia that's produced by acupuncture.
Well, speaking of pain, it's been said, and I don't know if there's any truth to this, that we don't have good memory for pain. Now, I'm sure that if you asked a woman about childbirth, she would disagree with you, or somebody who has passed a kidney stone, they'll say it was the worst pain of my life.
Well, you can remember that it was awful, but you don't really remember exactly what it felt like.
Yeah, is that true? And do we have difficulty remembering pain?
Well, we do in many circumstances, and childbirth may actually be a special case. I mean, obviously, if the memory of childbirth pain is very, very strong, then what woman is ever going to want to have a second child? And this is something that would be selected against in an evolutionary scenario. So the thing to realize is that intense pain produces the secretion of endorphins and related molecules, and these are analgesics. And so when that system is engaged, that can reduce both the perception of pain and it also seems to reduce the memory of pain. So if you give people drugs like Narcan that block endorphin receptors and you give those, for example, prior to an intensely painful stimulus, then the memory for that painful stimulus will become stronger.
Dr. Linden, how can we nurture our sense of touch? What is the best way for people to really kind of understand and appreciate this sense that we often take for granted?
Well, the bad news is that we have the highest density of touch nerve endings in our skin at age 20. And after that, it's all downhill. You lose about 1% per year of your life thereafter. You don't notice it when you're young. You don't notice it when you're middle-aged. But by the time you're old, you've lost a very significant part of your touch sense. And unfortunately, that marches onward. There's nothing one can do about that. You will lose your touch sense as you age. What we do know is that like other kinds of brain functions, there is a use it or lose it phenomenon. So if you seek out tactile experience, if you seek out interpersonal touch, even with strangers in the context of massage, for example, this seems to keep the touch-activated parts of your brain active, and you can do the most with what you have left.
Dr. Linden, one of the most challenging complications of diabetes is something called peripheral neuropathy, in which people lose that sensation of touch in, for example, their feet. And so it becomes very difficult for walking and for sensing unevenness in the area that you have to traverse. And I'm wondering, have you looked into this issue of peripheral neuropathy, and is there anything people can do to either cope with it or even reverse it?
Well, there's nothing you can do to reverse the nerve growth. It seems to be gone forever at this point. It may be in the future that there will be growth hormone therapies that will come down the line, but they're not here at present. I think one of the most important things that you can do is to take your shoes off or to wear very thin shoes that have very grippy soles. And this is the case not just in people with peripheral neuropathy, but in the elderly generally who have lost a lot of sensation in the soles of their feet and in other places through normal aging. And when that happens, then, as you said, it's harder to get a sense of the ground underneath your feet. And this is one of many contributing factors to devastating falls in the elderly, the other factors being things like muscle weakness and problems with balance.
We don't often spend very much time thinking about touch when it comes to our mouth. I mean, there we think of our sense of taste, and yet the texture of food has a really profound impact on how it tastes. Can you tell us a little bit about the sense of touch when it comes to food?
Absolutely. Touch sense in the oral cavity is extremely important in judging food. I mean, think about a soggy, limp French fry versus a nice, crisp French fry. Think about an apple that snaps when you bite into it as opposed to a mealy apple. Most of the sensory information that you're getting that determines something good from something bad in that situation is not coming from the 5 tastes on your tongue. It's not coming from the 400 odorant receptors in your nose. Rather, it's coming from the touch receptors in your oral cavity. The other thing that's very important to realize is that some of the things that we think of as taste sensations are actually touch sensations. So when you eat things with hot chilies, they're actually activating a touch receptor in your oral cavity. When you eat mint and get a cooling sensation, that's also a touch receptor. When you eat horseradish and get that pungent sensation from wasabi, that is also a touch receptor in your oral cavity. It is not taste.
Dr. Linden, I wonder if you could expand just a little bit on that idea that hot chilies are activating a touch receptor.
Yes, so we have a specialized nerve ending for touch, and it uses a sensor called TRPV1. And TRPV1 is normally activated at temperatures around 103 degrees Fahrenheit, and so when your shower gets too hot, it activates TRPV1, for example, and causes you to turn the water down. But the active ingredient in chili peppers called capsaicin, this chemical can artificially activate TRPV1. Plants evolved this as a way of reducing getting preyed upon by certain animals. And that's the link between heat and chili peppers. And it's the reason why all over the world people call chili peppers hot, even if they're experiencing them for the very first time. The very same thing happens with menthol, the active ingredient in mint, which activates a protein called TRPM8, which is the cold receptor in nerve endings, and that's why mint feels cool.
Dr. Linden, what should our listeners take away from your book, Touch, The Science of Hand, Heart, and Mind?
They should take away the understanding that touch as a sense is intrinsically emotional. There's a reason why feelings are called feelings and not sightings or smellings. There's a reason why when someone is emotionally clumsy, we call them tactless. There's a reason why when we are emotionally affected, we say, I am touched. And that is because the sense of touch is deeply and intrinsically emotional. And I think in terms of the news that one can use, this means that throughout your life, you should seek out tactile experience and in particular interpersonal touch to the greatest degree possible.
Dr. David Linden, thank you so much for talking with us on the People's Pharmacy today.
Thanks for having me on.
You've been listening to Dr. David J. Linden. He's a professor in the Solomon H. Snyder Department of Neuroscience at the Johns Hopkins University School of Medicine. He was formerly the chief editor of the Journal of Neurophysiology. Dr. Linden is the author of several books, including The Accidental Mind, The Compass of Pleasure, and most recently, Touch, The Science of Hand, Heart, and Mind.
Lynn Siegel produced today's show. Al Wodarski engineers the program. Dave Graydon edits our interviews.
The People's Pharmacy is produced at the studios of North Carolina Public Radio, WUNC.
The People's Pharmacy theme music is by B.J. Liederman.
The People's Pharmacy is made possible by Red X Industries, makers of Utterly Smooth Extra Care 20 Cream with 20% urea. 800-345-7339, online at uttercream.com.
To order a CD of today's show or any other People's Pharmacy broadcast, you can call 800-732-2334. Today's show is number 998. That number again, 800-732-2334, online at peoplespharmacy.com.
When you visit our site, you can check out prescription drugs, herbal medicines, and home remedies, and tell us your thoughts about today's show.
Sign up for our free online newsletter or the free podcast of the show. You'll never miss another People's Pharmacy program again, and you can share it with a friend. It's all at peoplespharmacy.com. In Durham, North Carolina, I'm Joe Graydon.
And I'm Terry Graydon. Thank you for listening, and please join us again next week.
We hope you enjoyed this podcast. If so, please consider taking a minute to write a review on iTunes. And thanks for listening to The People's Pharmacy.